So last lesson we finished at this question, like we learned what is a discrete probability table and what's the condition for a table become discrete distributions. There's two conditions. The first one, the x value, the probability for each x needs to be in between 0 to 1. And the second, if you add all of those values, that should give you a 1. And that can make a discrete probability distribution or discrete probability table. So we learn how to set up a probability table by ourselves. So we investigate example 6, which is a case we trying to chosen cards from 52 cards. We select 2 and we talk about the number of clubs we may get. Okay, we may get 0 club, 1 club, or 2 club. There's 3 possibilities. So my x can vary between 0, 1, or 2. Okay, so there's 2 different cases. The first one, they're talking about we can replace that back. Okay, we can replace that back. So basically, each trial, all the probability will stay the same. The first trial doesn't really influence the second trial. But in the second case, like this is a harder one. This one we talk about if we don't replace the card back. What's the probability of getting 0, 1, or 2 clubs? Okay, this one, the previous trial will get influence on the second trial. So we use a tree diagram to think about that. But, okay, you can see in VCAP paper, okay, so there's a course change, I think in 2005 before. And then recent changes last year, okay, recent changes last year. Last year, the first year of the new study design last year. So it's basically every 10 years they change the course outline, they change the study design. But before 2005, there's a lot of questions about this. Okay, so it's actually going out of the study design for 10 years and now it's coming back. So you can track the examples before 2005. There's some examples there. I'll just go through the exam papers and I see there's quite a lot of this type of questions. So if we think about chosen 2, it's still possible to set up a tree diagram. But if you think about if you select 5, do you still want to set up a tree diagram? It's impossible to set up a tree diagram, or like even 3 will be very painful to think about because every time you need to think about what has gone, okay, what's the previous trials and what has been like taken out. So we will use the hypergeometry distribution. Okay, I'm not sure if you're still familiar with that. It's not really a combination. This is in that exercise, but it's not really talking about like a combination method. So this is called a hypergeometry. It's called hypergeometric distribution. As you have learned binomial distribution last year, so there's like a lot of things, or normal distribution, you may heard about that, which is the bell curve. So we may heard about all of that distribution. One type of distribution is called hypergeometric distribution. It is selections without this replacement. So it's selection without replacement. I'm not going to replace back whatever I take before. Okay, this is called a hypergeometry distribution. And as you may know, or you have learned your Unit 3-4 course earlier, like on your calculator, there's a lot of functions can help us to calculate binomial distribution or normal distribution or inverse normal distribution. But the only thing calculator cannot do is this hypergeometry, which is purely based on your brain. Okay, you need to think about the case and set up the equation and then put the equation into the calculator and ask the calculator to do for you. So hypergeometry is not going to work on the calculator, even though there's a name for it, but there's not a uniform way of doing this because we need to analyze the case. So if, let's say, we are a girls' school. We don't really have boys or girls. Let's say we have a mixed school. Has some boys, some girls. Like say 20 boys and 10 girls. Okay, we have 20 boys. Well, that's just an example. Okay, you don't really need to write that down. Have a think about that. We have 20 boys and 10 girls. So we plus that, we have 30 people in total. And And what we want to do is to select a committee. Okay, we want a committee. Okay, in this committee, we want 5 people. Okay, want 5 people only. But there's restrictions on those 5 people. It must have 2 boys and 3 girls. I must have a combination like that. I must have 2 boys and 3 girls. Okay, I want this particular combination. Well, who is those boys? It doesn't matter. I just want 3 boys and 2 girls in this committee. There's multiple ways I can select it. The question is, what's the probability I can achieve that? Okay, you know, like I can combine any 5 students together to make one committee. So in this case, this is selection without replacement. Because if someone has selected me out, they can't replace me back and select me another time. I can't be 2 persons like in the committee. So this is a case without replacement. Once you have select me out, I'm out. And then you will select another one. So this is a without replacement case. So this case, what we're trying to think about will be, what's this 5 people, like the allocation of these 5 people? You will have 2 boys from 20 boys, and you will select 3 girls from this 10 girls. So you will think about those 2 components. Where are they coming from? Okay, some components coming from those 20 boys, and some component coming from those 10 girls. And we'll think about what's the total number of combination. The total number combination will be the denominator. The total number of combination will be 30, and you will select 5 from that 30. So you have 30 people. Doesn't matter you are man or woman. I just want to select 5 from the 30 without any thinking. I just randomly grab 5. This is the total number of way I can set up the committee. But because there's restrictions, there's a limited way that I can set up this committee. So I need to select 2 from this 20, and I will times select 3 from this 10. Okay, where is 3 coming from? This 3 must coming from the group of 10. Where is this 2 coming from? This 2 must coming from the group of 20. Select 2 out of 20 is the total number of ways I can select 2 boys from 20 boys. And 10-3 is the way I can select 3 girls from 10 girls. And I times that together. That's the total number of ways I can set up a committee with 3 girls and 2 boys. Over the total number of ways, that will give me the probability. Okay, girl equals to 3, intersex boy equals to 2. The probability of that will equivalent to this. Okay, so what's the classification in this question? It's like boys and girls. Okay, so I have 2 groups, boys and girls. Okay, that's 2 groups. And I select some from one group, some from the other group. So let's come back to think about the current question. Selecting clubs. Selecting clubs. Okay, we have 52 cars in total. But how many cars with clubs? Well, there will be 2 groups, with clubs, without clubs. How many cars with club? 13 cars. And club not will be 39. Okay, in the first one, I want 0, x equals to 0. Which means this is equivalent to I want 0 club intercepts 2 club not. Right? I want 0 club intersects 2 club not. X equals to 0 means club and club not. To give you both numbers. And that will equals to, okay, select 0 from the 13 clubs. And select 2 from the 39 not class card. Over the total, what's the total? The total will be 52. You will select 2 from the 52. That's the probability when x equals to 0. Okay, that's the probability when x equals to 0. Okay, let's have a look what that equals to. Just open the calculator and I'm showing you where's the combination. Okay, is menu number 5 probability and combination here number 3. Okay, this is called combination. The bracket is called combination. So it's NCR thing. What's the NCR? So first we want 13 select 0. What? That's a 1. You know that's a 1. Okay. So something is N0 equals to 1, N equals to 1, and N1 equals to N. That's something you need to know. So you select 0 things from 13 things. This is basically one way of doing that, not selecting anything. Okay, there's only one way of doing that, not selecting anything. So that's just a 1. So basically we have 39 and then comma 2. Menu. So you can copy that again. Drag that down. Oh. Control C and Control V, which is here, and this you will change to 42. 52 select 2. And you calculate that. That's a 19 on 34. That's a 19 on 34. So those two should give you a 19 on 34 in the end. You add them up, that should give you a 19 on 34. Because that's when x equals to 1, right? When x equals to 1. 2 cases give you x equals to 1. So the add up should give you 19 on 34. And you think about number 2. Probability x equals to, oh, that's equals to 0. Sorry, that's not equals to 1. That's equals to 0. Equals to 0 is the last one. So it's 19 on, what is it? 19 on 34. This is 19 on 34. Sorry, put in the wrong way. X equals to 0 first. It's 13 on 94 and x equals to 1. So x equals to 1, you will select 1 from the 13. And you will select 1 from the 39. Okay, 1 from the 13, 1 from the 39, and then over 52, select 2. You just have to think how many cars I need from each group, and that's how we can do it. So 13, 1, which is a 13, 39, 1, which is a 39. So this number will be, okay, copy that down, 39 times, plus times 13. 39, 1, which is a 39, 13, 1, which is a 13. N1 will equals to N. Okay, N1 will equals to N. So have that. 13 on 34. Okay, 13 on 34. Okay, 13 on 34 here. And the last one will be PRX equals to 2. I want 2 clubs, which means I need to reduce the number in not clubs. So 39 will select 0 and 2 select from 13. And the total will be 52 over 2. So will still be that. Total never change. I still select 2 cars from 52 cars. And this probability should give us, let's copy that down. And this will change to a 13. Because 39, 0 is 1. 39, 0 is 1. So I just have 32, select 2 from 13 and select 2 from 52. and that gives me a 1 on 17. A 1 on 17. So x equals to 2 will be 1 on 17. You can try to add all of that. That's a 2 on 34, right? So 2 plus 13 is 15. 15 plus 19 is 34, which makes a 1, which is correct. If it's not make a 1, which is wrong, because the probability distribution table add up should gives you 1. So you can recheck it. And also using the tree diagram should give you the same number. Okay, using the tree diagram. For example, for the first one, a quarter times 12 on 51, that is just like a 3 on 51, which is 1 on 17, which will give you 1 on 17 here as well by using the hypergeometry method. So do not use tree diagram when you're dealing with too many things without replacement. Like if the procedure is more than 2, you shouldn't use tree diagram. It takes you too long to do it. So you will think about this hypergeometry. We will come back to this point later for the last chapter. Last chapter we'll use that a lot. Okay, last chapter we'll use that a lot. So I will do that once here and I will do another time in the end. Okay, this is just this question here. You will set up a similar table to that one and change the number inside. Become a 17, 1 on 17, 19 on 34, and 15 on 13 on 34. Like you change the table. So that's this question. Anything you want to ask from that question? Okay, so after this page, it's become new things. Okay, it's pretty new things. That's all the revision part. That's all the revision part. So next page is a really important thing because you keep using that for all the chapters like after this page. Okay, so you basically use that again and again and again in every chapter. So what's this chapter talking about? We're talking about probability. Okay, we're talking about probability. We're talking about there's a random variable. Okay, there's a random variable. And then we talk about in some case it can be 0. In some case it can be 1. In some case it can be 2. In some case it can be 4 and so on. And you have the probability corresponding to them. But give you this table. You can't tell much about it. So you can just say, oh, the probability of getting this 1 is 19%. The probability of getting a 0, it can be 17%. But what that means, what that can really apply to the, to your work or something like that, what's the really application to it? So we want to analyze all of this data. We want to analyze a case. We not really need to look at the table itself. We need to look at another 5 factors, another 5 values, which is expected values, mean, median, this is called the mean as well. Expected value is called mean as well. Median, mode, variance, and standard deviation. So we talk about 5 things. In every distribution, in every probability question we learn, we only ask those 5 things basically. Okay, so those 5 things are everything they may ask. Okay, everything they may ask. So just that 5 things. Okay, let's look at that one by one. Okay, let's look at that one by one. It might take me 1.5 lesson to finish that. It's a pretty long thing because I need to introduce fully here and then you can keep using it later on. So the first one is expected values. So the expected value is what you expect a number can appear in this case. Okay, so remember, your expected value not necessary to be the possible value for the x. For example, your x can take 0, 1, 2, 3, 4. My expected value can be 2.4. It's possible to take that. it doesn't really need to be the value you have for your x. It can be a value like with decimals, which is not really exist on your list. So it's still possible. So that's the first thing you need to know. And what is the expected value? The expected value of a random variable is called the mean as well. We use capital E and a capital X in the bracket to represent that. This means it's a mean value for the random variable x. And this value can be represented by mu. Okay, it's like a u. Okay, it's like a mu. This is like a mu. So long tail over that side. Okay, so expected value is mu. When I say mu, it's expected value. So what's the formula for expected value? Okay, let's analyze this formula. This formula means it's a summation. A summation of what? It's a summation for all the x values. Okay, your x can be 0, 1, 2, 3, 4, 5. Like, I don't know what are they. Like, it can be some values. But it's a summation of x. Okay, what's the formula? So the formula is the x itself times the probability of achieve that x. So a 0 may appear. And then I will times the probability of getting that 0. And I have 1, and I'll times the probability of 1 occurring. So if I'm going back to this table, for example, this table. This is a table, you just look at mine is enough. So what's the expected x? The expected x will be the individual x times the probability of achieving itself and plus all of that together. So you use the 0 to times the probability of achieving the 0 plus 0.5 times 1 plus 2 times 0.2 plus 3 times 0.1. Basically, in the table, you will vertical times them and horizontal add them. Okay, so it's the number itself times the probability of achieving itself and plus all of those numbers together. That will give you expected value. That's the definition for expected value. So it's quite makes sense. The probability of that occurring times the number, like that's the what you expect that can appear. So for example, I have like 10% sure that the number 100 can appear. So you have 10, like the expected value will be 10. So it's 100 times 0.1. So same case here, you times them all together and plus them. Okay, that's the first thing. Okay, but we have some combination. I need to keep changing back and forward. Okay, so the next thing we're talking about is there's a linear transformation. So if I know my expected x is 2.4 already, so I may ask, what's the expected value for 2x plus 1? That's a question I may ask. What's the value for expected 2x plus 1? This will be a linear transformation. That will be just 2 expected x plus 1. Which will equals to 2 times 2.4 plus 1. Okay, so that only appear for linear. Okay, this only work for linear. If it's not linear, let's say, like, see the question here. Expected gx is not equivalent to g expected x. So what that means, I'm trying to work out the value for expected 1 on x. This will not the same as 1 over expected x. You can't do that. Okay, you can't do that. Or say expected x squared is not equivalent to expected x and then squared. They are not the same. You can't do that. But for linear you can. Okay, only works for linear. Linear is good. Linear I can just directly do that. So what's the probability of getting expected gx? So for example, I want to evaluate what is expected 1 on x. What is the expected 1 on x? What I can do? I will use the gx value to times the probability of x occurring. So example, okay, always helpful to look at example here. Where's my example? Here. Okay, still look at this question. Okay, now I want to look at for expected x squared. Okay, I want to find expected x squared. I want to know the value for that. What I will do is I will add another layer here. And what I want to find, x squared. So I will do x squared here. So what is x squared? X squared is 0.149. That's my x squared. So what's the expected x squared? You use x squared to times the probability of x. It's 0 times 0.2 plus 1 times 0.5 plus 4 times 0.2 plus 9 times 0.1. Okay, so you use the x squared value to times the probability of x occurring. Get the probability of getting x. So it's x squared times the probability of x. Okay, so similarly, if I want to, for example, do this question, I want to do what's the probability for 1 on x? What's the probability for 1 on x? So again, I will set up table on the top. I can't do 1x. I can do 1x plus 1. Okay, do 1x plus 1. So what is 1 on x plus 1? That's 1. That's 1 on 3. That's 1 on 5. That's 1 on 7. Okay, I have worked out those values. And that will be 1 times 0.5 plus a third times 0.3 plus 1/5 times 0.1 plus 1/7 times 0.1. And you will calculate that. That will give you the probability of 1 on x plus 1. Okay, that's how we do the expected values. Okay, that's how we do expected values. We not only do expected value for a single x, we also do expected value for gx. Okay, it's an equation for x. So that's how we do this type. So we have linear of gx or not linear of gx. If it's linear of gx, it's easy to do. It's just a expected x plus b. So if it's not, then it's just set up the table for another layer and you calculate in this way. I have a question. What do you think is the expected value for a constant? Let's say, what's the expected value for 3? 3. Okay, it is 3 because 3 is 3. What do you expect it will be? It will be expected is 3. Okay, so expected value for a constant is just that number. Why we have expected values? Because the x is changing. So I will expect what that's going to be. But for a constant, it's already 100% sure that's this number. Okay, so you will expect it to be a 3 later on as well. So expected value for a constant is still the same expected value. It's the same constant. Because we'll do that later. Okay, we'll use that later. Okay, median. What's the median? Median is where your 50% exists. Okay, where is your 50% value? So let's do some examples. Okay, let's still use this table here. Okay, just look at this table. Okay, those bottom 2 lines. First of all, your x value needs to be least in order. Okay, your x value needs to be least in order. So 0, 1, 2, 3, that's good. Okay, that's good. And then we look at the probability. For 0, you only have 0.2, which is not reaching the 50% yet. And then you go to 1. So it's 0.2 plus 0.5, which is 0.7 already. Is go outside than 0.5. So the median will be 1. Because the 0.5 exists in 1. Okay, it exists in 1. Because when it's 0, it's not reaching 0.5 yet. After the 1, after you finish 1, it's go outside than 0.5. So where is 0.5? 0.5 will be somewhere in the middle of the 1. Okay, so 1 is the median. 1 is the median. Okay, let's have a look at this one. What do you think the median for this one? First of all, x needs to list in order 0, 2, 4, 6, which is good. But what do you think the median will be for this question? Have a guess. Have a guess. What's the median? Median is the 0.5 place. 0 is like just 0.5, and then all the rest is 0.5. So the median will be in the middle of the two numbers. So it's in the middle of 0 and 2. So your 0.5 is cut into half here. Okay, that's your 0.5. So your median will be 1. You can see the difference between those two questions. One is the 0.5, like the one number before is not yet, and then after you add one number is outside. So the 0.5 will just exist in the middle of the second number. But in this case, your 0.5 is just half split. So the median will in between the two numbers as well. So which is the average of that. So which is 1. Okay, let's have a look at if you have any other. Okay, like in this case, that's 0.2. So what's the median in this case? Five, right? 5. Because 1 is 0.2, plus the 0.2 is 0.4, not yet, and you plus another 0.2 is 0.6, which is outside 0.5, which is 5. Okay, which is 5, so it must be 5 there. Let's have a look at this one. That's 0.25, 0.3. Well, enough. 2 is enough. What's the median will be? 1. Okay, median is 1. So 0.25 plus 0.3 is 0.55. It's go outside. So 1 will be the median. But if it's just 0.5 and 0.5, 0.5 on the left, 0.5 on the right, then the median will exist in the middle. Okay, will exist in the middle. Do I have another example here? Well, another example is here. What's the median for this question? Okay, it's just cut half here, 0.5 and 0.5. So it's 1 plus 4 divided by 2, which is 2.5. Okay, the median is 2.5 here. Median is 2.5 here. Okay, that's the median. Shh. Okay, next one is the mode. Next one is the mode. Okay, mode is the most frequent number. Okay, it's the most frequent number. So just look at the probability. Which one get highest probability? Then that is the mode. So, okay, in this case, what is the mode? 0 is the mode. Okay, 0 get the probability of 9 on 16, which is the largest probability. 0 will be the mode. Okay, in this question, what is the mode? 7 is the mode. Okay, I'm not going to do the rest. So mode is easy to understand. Okay, next one, come to the most difficult one. Okay, variance. Okay, because I find from year 9, like we start to like reject to teach statistics, and I think that's not a good thing to do. So that's how we talk about variance in statistics. So what is variance? What is actually variance measured? Variance is actually measure the spread of all your data. Okay, it's the spread of all your data. So have a think. If I have 2 sets of data, if that's a 0 here, okay, I have a set of data like this. It's quite small here, but I hope you can see it. So I have the first set of data is -5, -3, -2, 0, 2, 3, 5. What's the average for this data? Very easy to see. 0. Like so, you all like symmetric about 0. So 0. What's the like? And then I have another set of data is -0.4, -0.3, -0.2, -0.1, 0, 0.1, 0.2, 0.3, 0.4. What's the average? 0. Mean is 0. Okay, it's all symmetric distance. Like you add them, they just give you 0 as the summation. Both data set gives you 0. They give you 0. But are they the same set? Like, is that like if we have the same expected value, it doesn't mean anything. Okay, I can't really see the spread of the data. I can't really make any decisions on that because I just know what is the average about, like what's the expected value about, but like I don't actually know how much or how far it can go after like the mean. Okay, so the variance is actually talking about the spread of your data about your mean, like how much it gets spreaded from your mean. Okay, you have a mean point here, and all the data is like allocated around it. It's how far it gets spreaded. So the larger the variance value, the more it gets spread. So if you have a variance of 4 and another one gets variance of 1, which means the 4 is got more spread of the data. It's like this, and the 1 will be really close to the origin. Okay, really close to the origin. So that's why we talk about variance. Variance is just like how much it gets spread. And if you talk about further, there's much use about it, but we're not going to talk about this in year 12. So variance of x. Okay, so how do we calculate variance of x? As I said, is how much it gets spread from the mean. How much it gets spread from the mean. So we're talking about the expected value. We're talking about the expected value for the data x. Subtract the mean, and then we square for it. And we square that. We find the expected value for that. Okay, so what's the expected value for that? Okay, let's say the expected value for that. Remember how to calculate expected value? We'll use x, lowercase x, minus the mu squared, and I will times the probability of x equals to that x. And I will sum around all of that x. I will find the sum for all of that. Let's just do an example here. Let's not look at the bottom line yet. I just do one example for using this data set. Use this formula here. So I just do a simple one with you. Have x, probability x equals to x, have 0, 1, and 2. Oh, I shouldn't have this here. I should have it on top. Okay, we'll have 0.5, 0.2, and 0.3. So quickly calculate the expected value. The expected value will be 0.0 times 0.2, which is 0, 1 times 0.3 is 0.3, and 2 times 0.5, which is 1, so that is 1.3. Then you will think about what is x minus mu squared equals to. X minus mu squared, what's that equals to? Because I want to find the expected value for that. So x minus mu, so that is 1.3 squared. That's just 0.3 squared. That's just 0.7 squared. Why we squared for it? We squared because we want to get rid of the negative. Because the distance can have positive distance or negative distance. After we square it, it's both become positive. So we want to get rid of the negative effect. So we will have that. Mu is given, mu is that. Okay, mu is expected value. So you use x minus mu and then we square for it. Therefore, expected x minus mu squared will equal to, well, if it's expected value, I need to times that with the probability. That's 1.3 squared times 0.2 plus 0.3 squared times 0.3 plus 0.7 squared times 0.5. Okay, we have that. That is how we use the first one. First one is basically the definition. Is how much we expected is spread from the mean. Okay, from the mean. So all the x value, all the x I can have to subtract the mean and I'll square for it. The square is trying to get rid of the negative effect. And then we find the expected values for all of those distance. That's the expected value for x minus mu squared. That is the definition for variance. Okay, that's the definition for variance. But there's another formula we must remember as well. This is something we need to remember. Okay, I'll highlight this one. Not this. In some case, we need to use this formula. But we can get some like extension from this one. Okay, we can get some extension from that. So what I'm trying to do is I want to expand. I will expand the inside become x squared minus 2 mu x plus mu squared. Okay, like quadratic formula, expand. And I will find expected value for all of that. Okay, so expect separate things. Like if they are plus or minus relationship, I can just separate that. Expect x squared, expect 2 mu x, and expected mu squared. Let's have a look at that. What is mu squared? Mu squared is a constant. Mu squared is a constant. So that is just come to mu squared. Expected of a constant is the constant itself, so it's just come back to the mu squared. And have a look at this one. 2 mu x. Okay, this is a linear. 2 mu is given. Well, you know what is 2 mu. It's 2 times the expected value. For example, it's 2.6 in this case. So that's 2 mu expected x. Okay, I can take the 2 mu out. We use the formula expected ax plus b equals to expected x plus b. Okay, we use that formula. So that become a 2 mu expected x. What is expected x? Expected x is mu, right? Expected x is mu. So the bottom then further become a 2 mu times mu. It's 2 mu times mu. So that's a minus 2 mu squared. That's a minus 2 mu squared. And then this one, you have a plus mu squared. Overall, those two give you a minus mu squared. And the expected x squared will keep there because you know how to calculate expected x squared. I have teach you how to do that. You want to find x squared first and you find expected values for that. You times all the probabilities and add them together. So that formula become a simpler version. Looks like that. Is the expected x squared minus the mu squared. Or I can say in some case it will write in this way. Mu is expected x. So it's expected x squared minus the expected x and then the whole thing squared. So finding the expected value for x squared and you subtract the mu squared. Okay, that's for the variance. So you must remember this formula as well. So variance got two formula, the top one and the bottom one. You can ignore the proof steps. Just forget about that if you don't know that how to do that. But you need to remember the two formula, the first one and the last one. That is important. Okay, the next is the linear transformation, which is really important. Really important. What's the variance for a constant? It's 0. It's given here. Okay, 0. Why is 0? Because it's not vary. There's no spread. The expected value for the constant is the constant itself. And the constant itself get a distance of 0. And it's not varying at all. There's no vary values. So it's true. There's no variance. It's 100% sure it's here. I'm not getting any spread. It's just stay at there. So the variance of the constant is 0. But the expected value of a constant is just that constant. Okay, do not mix up those two. The variance of a constant is 0. But the expected value for a constant is still that constant itself. And now I have another thing, which is the variance linear transformation. So for expected ax plus b, we have a expected x plus b. That's for expected value. For the variance ax plus b, that's the variance ax plus the variance of b. And the variance of b just become a 0 because that's the variance of a constant. That's just become a 0. And you need to remember that. Okay, the variance of ax is just a squared variance x. The a will come out but become squared. Remember when we calculate the expected, it's x minus mu squared, and then we calculate that. So that's why the a will be squared as well. So you will square that. So in the end, we need to remember this one become that. The b just disappeared and the a will get squared. The a will get squared. For example, if we have variance x equals to, well, variance is always a number greater than 0. Remember that. Variance is always greater than 0. Or equals to 0, like it never less than 0. Because it's talking about the spread, what negative spread means, like it doesn't make sense. So it must be always greater than 0. So the variance of x, say, equals to 3 over 2. So I want to know the variance of negative 4 on 3x minus 1, what that equals to. That will equals to negative 4 on 3 squared times variance of x. And that's a 60 on 9 times 3 over 2. And that will give you 8 on 3. Okay, that's just an example. I'm just make a random example. So how we do linear transformation for variance. Okay, linear transformation for variance. Okay, next one, the last one is standard deviation. So standard deviation, what we can say about standard deviation is another way of talking about the spread. Well, it's equivalent to variance. It's equivalent to variance. It's just another way of talking about like spread. Well, instead of saying variance is blah blah blah, I will say standard deviation is blah blah blah. That basically means the same thing. Well, again, the smaller of that number, the more central to the, like, get close to the center. So what is standard deviation? Standard deviation, we use this sigma to represent that. It's like an O with a bar on top. It's like sigma. This is called sigma. So standard deviation equals to that. Equals to square root of variance. Equals to square root of variance. There's not really a meaning, it's just a formula for that. So variance equals to standard deviation of that. Because why we need standard deviation? In a lot of distribution, we use standard deviation to calculate instead of variance. Okay, we can use the formula to talk about the variance first. Because there's no direct formula, I can directly calculate standard deviation. After we calculate variance, and then we convert that into standard deviation, and we use standard deviation to do a lot of calculation. We talk about standard deviation more than variance, but we need the formula to calculate variance to give us the standard deviation. Okay, so we need to get the variance first, and then get standard deviation. They are basically the same thing, but the calculation is to variance. And the variance convert into standard deviation, and we use standard deviation to talk about a lot of things instead of variance. Okay, you know that later. You will see it's very important to use standard deviation. So standard deviation is just the square root of variance. Okay, it's the square root of the variance. And then we will think about the linear transformation. We will think about the linear transformation again. It's different again. So standard deviation AX plus B. It will be the same as the square root of variance AX plus B, right? Variance standard deviation X plus B will be the same as square root of X plus B. And that variance X plus B will be A squared times variance of X. A squared times variance of X. I will separate them. Square root A squared times variance of X. So variance of X just becomes standard deviation, the standard deviation dx. But the square root A squared will become an absolute A, not A itself. Why? Because think about, if it's square root of -4 squared, what that equals to? That equals to 4 instead of -4. It's not going to be the same A value. It's the absolute value of A. So that's why we need the absolute sign there. Or you can just remember, variance is positive, standard deviation is positive as well. If you have a negative number, you're not going to times that negative number. You times the positive of that. Because what's the meaning again with the negative spread? There's no meaning for a negative spread. So let's say we have SD equals to a half. So SD negative X plus 1 will be, let's say negative 4x plus half. That is absolute value of -4 times SDX, which is 4 times a half. That gives me 2. That gives me 2. So 3 linear transformation for expected value, variance, and standard deviation, they are all different. Okay, they are all different. The expected value is the easiest one. Whatever you see, you just apply to that. Variance is a little bit harder, and standard deviation is a little tricky. You need to think about the absolute value for A. Okay, the next one. The next one is not very helpful in this exercise, but it will be very, very helpful in the later exercise when we learn continuous. So what is actually talking about? For many random variables, about 95% of the distribution is within 2 standard deviation of the mean. which is probability x between mu minus 2 standard deviation and mu plus 2 standard deviation, is approximately 0.95. So what that means, I have a table. Let's say we have more. I have x and the probability of x. And I have, for example, 0, 1, 2, 4, 8, and 10. Well, I'm not going to give the probability, okay, because I may give a wrong one. Let's just assume the expected value after we calculate that will give me 4.4, let's say we have a 3. Expected value will give me a 3. And then let's talk about the standard deviation. Well, let's say variance x gives me 4. Then standard deviation will give me 2. Okay, what means by within 2 standard deviation from the mean? So you have the mean standing here. Mean is here. Okay, mean is here. Go standard deviation 2. Okay, 2 standard deviation from each side. You go 2 standard deviation from each side. Let's say that's a -2. So we will have, okay, that's 1 standard deviation, which I have a 2 here. And then I have, no, that's a 1 here. And then go 2 standard deviation, I have -1 here. I'll go 2 standard deviation, that's a 5 here. And then 1 standard deviation, that's a 7 here. So that's 1 sigma. That's another sigma. So here to here is 1 sigma. Here to here is another sigma. So that's the mean. That's the mean. I'll go to 2 sigma from both sides. So the boundary will be -1 to 7. The boundary will be -1 to 7. Okay, go each side for 2 standard deviation. So go back to my table. My data from -1 to 7 will, well, -1, it doesn't really exist on the list, but to 7, which will stop here. This is all the data I have in between -1 to 7. If I add all of this probability, that should give you approximately 95%. You add all of that, that's what the series is talking about. That's approximately give you 95%. But it's not very, well, it's very inaccurate in those cases, like it's just a random table. But if we're talking about some distribution, like binomial distribution, like normal distribution will be the very accurate one. If you talk about some distribution, then this one will work very well. Well, if you just take a table and calculate that, it's not going to work very well. I will show you that later. But this is the theory. You just need to remember the theory. From the mean, go each side by 2 standard deviation. The probability to cover those values will be approximately 95%. That's what the theory is talking about. Okay, so that's all the theories we have, and you don't have class tomorrow. So I want you to complete the homework for the rest 3 pages. Okay, it's basically finding mean, median, mode, expected value, standard deviation, and combination of linear transformation of x. Okay, so those 3 pages are the same type. You at least need to do 2 pages. Okay, you at least need to do 2 pages. If you can't do this exercise, you can't do the rest. Okay, you need to know how to do this. And before we start next exercise. Also, please print your notes for the next chapter and take that to Wednesday lesson. We'll start binomial distribution on Wednesday.